So this is our last type. These are our slant asymptotes. So you can see here our degree for the top is bigger than the bottom. We start them exactly the same way and work through them the entire same exact way. We just are going to have a different type of asymptote at the end. So we factor this out. Nothing cancels. So our only domain issue is x. Let's put that in red. X cannot be 1. So that means we go from negative infinity to 1 and 1 to infinity. That is our domain. So x-intercepts. Again, x-intercepts are the top. So we have x equals 0 and x plus 2 equals 0. And so those are our two x-intercepts. So we're going to have one at 0, 0 and one at negative 2, 0. So we can come down here and plot them. One at 0, 0, one at negative 2, 0. Okay. Y-intercepts. If you remember the y-intercepts, we just plug in 0. So we get y equals 0 squared plus 2 times 0, 0 minus 1. And so that would give us 0 over negative 1, which is 0. And so we have 0, 0, which we've already plotted. It's right there. So that is our x and y intercept. So now on to vertical asymptotes. And again, vertical asymptotes are the denominator. We only have 1 here. So we have our x equals 1 because we had x cannot be 1. So we go to 1 and we draw our vertical asymptote. Now the last one we have, this is now considered a slant or oblique asymptote because our top degree is bigger than our bottom degree. So we use synthetic. So we're going to take our x squared plus 2x and divide it by x minus 1. So we end up with 1, 2, and 0. So there is no 0 there. And we're dividing it by 1. And again, this is our remainder. And the remainder goes off to 0. So we end up with y equals 1x plus 3. So we go to 3, put a dot, go up 1 over 1. And then if you follow that along, that y equals 1 line, like that, that is our slant asymptote. So you can already see that this one has a graph here from our intercepts that goes down, comes up, and then comes back down this way towards our slant. Oops, I crossed. Don't cross it. It approaches it. So again, as we go to infinity, it's going to go down to negative infinity and up to positive infinity. And we throw it in our calculator, and we get this. So that you can see that asymptote, what we're going to do is actually graph the asymptote this time as well. Y equals x plus 3. So we're going to go here, and I've already got them both in. This is to verify that our factoring is correct. Y equals x plus 3. And so now when I hit graph, it will draw that nice slant asymptote. So you can see our graph is approaching left and right to that. So everything is perfect. If this was to cross or this was to cross, it wouldn't be good. So now you just have to draw that upper part here, like that. And again, if you want exact points, you can use the table function to get exact points, but I just need a rough sketch. So there you go. That is how you do the slant asymptote. So all you're going to do is do a little synthetic division, top and bottom. If you can't use synthetic, you got to use long division. And then there is your graph. Thank you.